So if you guys have problems uploading your videos for your kinematic stuff, Jared just told me that they set up a folder, a groups folder in the ME471 thing. So you hopefully should be able to upload your stuff there.
NT might have trouble doing that.
Yeah, and if that's the case, I'll see if I can move the videos that are currently uploaded in TCC over to that so that they can upload to TCC. So that'll be enough space. Okay, so today we're going to do Lab 13. This lab is basically taking a cross-sectional 2D cut of your vehicle, taking it and putting it into hypermesh and creating some inlets and outlets and walls so that you can kind of allow a simulation to simulate air flowing through like a tunnel, like a wind tunnel. And then once you're done with all of your meshing and whatnot, you will move that model to ANSYS, where you will run the actual analysis in Fluent. So the tutorial that we have uploaded here on Team Center Community basically walks you through step by step what buttons you need to click. So we're not expecting you guys to become fluent experts like you guys are with Catia and Hypermesh. So just kind of follow the tutorial step by step. I'm going to show you guys how to take a 2D cross-section cut out of Catia and turn it into an IGES. And then Eric will show you kind of everything from the Hypermesh portion up to the end. So for the actual assignment, it's 20 points for part 1. Basically, follow the tutorial utilizing your CAD system, Hypermesh, and ANSYS. You may use the car shell mod.part available on TCC. I just barely uploaded that. So just look for go to the Lab 13 folder, and there should be a CAT part up there that says something like car shell model test or something like that. That's the part that I uploaded. So you'll use that, and then basically for the homework, it just says use CFD to improve your semester project. So we're not going to ask you guys to do something to turn it in. If we can get done with the in-class assignment, you guys can turn it in, and you won't have to worry about anything else. So hopefully that'll give you guys time to model your vehicles, get all of the parts modeled, do some topology, get the results in, do some analysis, whatever you guys haven't finished into your final presentation. So anyway, the final result will show something like this. The blue section shows low pressure, so that's usually bad for a vehicle. But anyway, we'll kind of go through it. So if you guys need anything on there, the tutorial is up on TCC. It's the 2D CFX tutorial. The actual assignment is Lab 13, and then this car surface model test is what I just uploaded. You guys can use that part. So if you want to go ahead and get into Catia and download that, we'll go ahead and start doing a CFD model. Hey, Alston, you there? Hey, so we were just finishing up a design review practice. One of the teams wanted to practice, but we are going to do the CFD analysis this week. For the analysis, everything's up on Team Center Community. Here, let me give you my join.me number. So basically, I just went over the tutorial assignment. The assignment is to do an in-class CFD, and then for the homework, you're going to apply that to your car. So there's nothing extra other than just the in-class assignment. We will be going through the tutorial that's on TCC, and we don't expect you to become an ANSYS fluent super guru. So you can use the tutorial to just kind of follow step by step how to do the lab. But we're just going to go ahead and start doing that. Okay, so if you open up Catia, I've uploaded a surface model part on TCC called Car Surface Model Test. And if you download that, you can open up Catia, and we're going to go ahead and bring that into our part here in a sec.
Do you do the part that you put up? Or?
Yeah, just do the part that I've put up. I don't expect you guys to do your own surface models for this in-class assignment.
And we don't have to do it for a homework
For the homework assignment, it's you're supposed to take the surface model of your vehicle and do a CFD analysis and include that in your project. So the only thing you'll turn in for this lab is what we're going to do here in class. So if you don't finish today, you have till Thursday at 4:45 p.m. Mountain Standard Time to get it turned in. Okay, so to do the first setup, we need to get a cross-sectional cut of our vehicle. And so inside of Catia, if you go to Start and go down to Digital Mockup, there's a DMU space analysis option that we're going to go ahead and utilize to get our cross-section of our vehicle. So you'll click on that, and then we need to bring the actual model in. So we're going to go to Product Selection. And
then you press product, maybe?
Actually, hang on one sec here. I think I can do add component. Should be able to bring it in. Actually, I think I've already got one open. That's probably why. Okay, here we go. Okay. And I brought it in the other day just doing that. So yeah, you're supposed to be able to insert. Oh, here we go. Yeah, so go up to Insert, go to Existing Component, and you can go navigate to your vehicle. So I think I stored mine in here. Yeah, there we go. Okay, so here's my car surface model that I did while I was getting ready for Lab 8. No, so I just went up to Insert, Existing Component, and then clicked on the product, and then I was able to select which model I wanted to bring in. Yep. So we've got our part in here. And then we want to take a cross-sectional cut of the vehicle. So to do that, there's this sectioning tool. So if you click on that, you can take any two-dimensional cross-section at any plane that you specify. So if you guys want to do a CFD model showing the airflow going over like the front of your car at a specific point, you can cut it right here. If you want to do a cross-sectional cut showing how the air flows over maybe the entire vehicle, which is what we want to do, you'll go ahead and select a different section. So you'll click on the Positioning tab, and you can select a different plane if you want to. So I mean, there's a variety of planes. We'll go ahead and do the Y plane. So just click on that, press OK. And then you'll notice there's a section window that has the cross-sectional cut of the vehicle. So it displays all of the geometry that is on that plane. So for those of you guys who might have like a DeLorean, you know, the back fins are not in the middle of the vehicle, and so you might want to take a cross-sectional cut slightly off the middle. But anyway, so you'll get this geometry here. We want to go ahead and save that section. So we're going to just do File, Save As. And actually, I want to click on this. I don't want the product. There we go. Properties. Give me one sec here. I just need to remember how to do this. I did this yesterday once, so I've got to remember how to do this again. Okay. So if I click on this. Okay. Oops. No, we don't want to save the product. You want to save the actual. Oh, shoot, I closed mine. There we go, export as. Sorry. So inside the sectioning definition, you'll click on your position and click the Y position. You'll go to result and you'll export it. So there's this little drop down, and you can export it as, or export and open.
How did you bring that back up?
It's just the sectioning tool. So I clicked on this sectioning.
So just
Yep. Yeah. Select the plane that you want. Go to the Result tab, and there's an Export button. And if you click that, it'll save it as a cat part. So I'm just going to call this like my car cross section. Press OK. And now if you go back into modeling, you should be able to just open that up. And it will just bring up a part. Okay?
Yeah, baby.
There we go. All right. So you should have something that looks like that. Is everybody there? Okay. It's really not too bad. So you'll export it. Yeah, you just export it and then save it as a cat part. Okay, so there's a couple other things we still need to do before we can export this out to HyperMesh to start meshing it. One of the things we need to do is we need to create a line across the bottom so that we have an enclosed surface. So we'll do a sketch at the plane that we did our cross section at, and we'll just draw a line that will connect those bottom points together.
You did a new sketch.
Okay, so we've got our line. We're also going to go back into the first sketch. Oh, actually, no, hang on. You just go into the first sketch, sorry. Go into the first sketch and draw the line so it's all in the same sketch. So once you got your line across the bottom of your vehicle, you want to trim out this line here on the interior. So we'll just bring up our trim tool. And we'll click on this line, and it'll just remove everything. Okay? So now that we've got that profile of our vehicle that we can take into HyperMesh, we need to define kind of an inlet and outlet and the walls between which the air will pass. So to do that, we're just going to draw a rectangle around the vehicle.
In that same sketch?
In the same sketch. Generally, the rectangle, you want it to be, what is it, Eric? It's like twice the length and twice the width? One car length in front. So let's see how big this is here.
So can we go too big?
New sketch or same sketch?
What are we doing now?
So you want one car length in front?
Is this a new sketch?
Same sketch. This is all in the same sketch.
This is like mucho fun.
Yeah, does the height have to be?
What about the height? Do you know this? Not too high. So something like that. And then let's check and make sure that we've got at least a car. Yeah, wow, that was pretty close. There we go. Something like that. And then 2 car lengths behind, you said? Yeah. So you'll want to extend the back quite a ways, about 2 car lengths. Okay, so that's everything that you'll need for this model. This will be your inlet, this will be your outlet, and then these will be the walls kind of defining the boundary that the air is going to flow through. Okay? So this is all done in the same sketch. You'll go ahead and hop out of the sketch. You'll do File, Save As, and you're going to save it as a IGES file.
Those are my favorite kinds of files.
So just type .igs at the end, and if you look into it, it should have saved as an IGES. Okay, Eric, I'll put this IGES file into the ME471 TA folder so you have access to it. Okay.
Just got new Southwest
Okay, I just put it right in the groups folder, ME471 TA. Okay. All right, so that's everything that you need for Catia. I'm going to go ahead and let Eric kind of take over, show you guys how to bring that rectangle and the cross section into HyperMesh, mesh it, and then export it to Fluent.